Hey, good afternoon, everyone. For those of you who are west of the Mississippi, good morning. I'm Paul Deffenbaugh. I'm the editorial director at Metal Architecture Magazine. Glad you've joined us for another in our metal architecture webinar series. Today, we're offering metal roof systems, design and installation considerations, which is presented by AEP Span. In a moment here, I'll turn things over to Jeffrey Medeiros, who's our speaker today. Jeff has a lot of material to go through, and we'll take a couple of breaks during his presentation to handle questions, and of course, we'll also handle them at the end of the presentation. You can submit your questions using the panel on your screen there. I know a lot of you are interested in how the certificates and AIA credit will work, and all of that will be handled automatically. The AEP Span are very efficient at this, so please allow 7 business days for everything to process. Tomorrow afternoon, 24 hours after the end of this webinar, you're going to receive an email with links to more information. It'll have ways you can ask technical questions, place a link to go view the webinar again, and also be able to download the presentation itself. As we begin here, let me introduce our speaker, Jeffrey Medeiros. Jeffrey is the architectural representative for AEP Span and a licensed contractor who's been supporting architects in California for more than 10 years. He can spec write, assist in detail drawing, and aid in production selection or any aspect of the design build process from initial design to complete bid-ready documents. Jeffrey's fluent in building code, bid laws, and contract code. He provides architects with full range of service from conception through bid. Jeffrey holds various degrees, including Law and Society from UC Santa Barbara, Japanese from Waseda University in Tokyo, and he attended McGeorge School of Law in Sacramento. He's fluent in all types of roofing systems, built up, torch glide, hot and cold process, restoration coatings such as silicones, urethanes, and acrylics, single ply roofing, and all forms of metal applications, including roof, wall, coping, and soffit, as well as flashing and trim. Jeffrey made the move to AEP Span, I think about 3 years ago, wasn't Jeffrey? After he spent a number of years at a competitor, and he plans to stay here through retirement. Jeffrey, take us away.
Hey, thanks for the introduction, Paul. We just dated ourselves. I think I've been with AEP 4.5 years now, and servicing architects in the design community for not 10, but almost 15. So my gray hairs are showing. Welcome everyone to Metal Roof System Design and Installation Considerations. I'm going to go through this presentation right here. Allow me if I can. There we go. Second page. I'm going to potentially skip a couple of slides just in interest of time if they're not too interesting and so on. And I may go off track a little bit. I'm known for that, but we'll take some pauses here and there so you can ask some questions. Here's your course number and your learning units. So let's get started. Learning objectives. Here's pretty much one of the 2 slides I might be reading. At the end of this program, participants will be able to list the advantages and disadvantages of architectural roofing versus industrial roofing, as well as the features of both, state the specification considerations related to a metal roof installation, discuss the energy efficiency and so on of the metal roofs, and list design and installation considerations and issues that help facilitate the installation of a metal roof. So let's begin this course with a discussion of the pros and cons of architectural roofing versus industrial roofing, followed by an overview of exposed fastener roof systems versus standing seam roofing assemblies. Specification considerations that are critical to a successful installation will also be reviewed, such as proper substrate, underlayment material selection, metal gauge, coating, sealant options, and so on. So let's start with the evaluation of the types of metal roofing applications. All right, architectural and industrial. The 2 major applications of metal roofing are architectural and industrial. Architectural roof system is specified for performance and life cycle costs, as well as aesthetic reasons, in that the roof is often part of the overall architectural design. Non-structural metal roofing usually requires a solid substrate beneath it, such as plywood or metal roof deck or rigid insulation over a solid substrate. Low-slope industrial roof systems, on the other hand, are selected more for their function, performance, and let's just be honest, when cost is the major factor of a project, feasibility, and so on. Structural metal roofing attaches directly to the secondary structural members and may not require any sort of substrate or solid support beneath it. Let's go into the advantages and disadvantages of both. So this is one of those slides we're going to blow past real quick because I'm going to touch base on this down the road. So exposed fastener roofing systems. Here's what I want you to take away. Not the architectural and industrial. I want you to take away exposed fastener versus concealed fastener. Okay, so exposed fastener roof systems. Number one, they are through fastened. You can see the fasteners. Number two, they're nestable. They stack on top of one another and they ship on a pallet. So they alternate just a little bit to the left, just a little bit to the right. So the profiles fit within each other and you can ship a ton of them very easily. And number three, they rely on laps and sealant for waterproofing. Okay, I don't care what the profile is. I don't care if it's a sine wave, a trapezoid, a box, diamond, whatever you want to do it. Corrugation is corrugation, and by definition, again, number one, through fastened, nestable, rely on laps and sealant for waterproofing. So this is considered a standard in the metal building industry for, oh gosh, what, 60, 75 years at this point? Exposed fastener roof systems, also known as the through fastened systems, provide an economical performance value option, durable, lightweight, available in all kinds of finishes, textures. You can install them on a roof. You can do vertical, horizontal on a wall application, and so on. Many exposed fastener configurations can be fabricated in numerous gauges, and they provide high negative and positive load carrying capacities. Note, some of them exposed fastener panels have been tested to provide diaphragm support. So this is one of those questions. Exposed fastener, through fastened, nestable, rely on laps and sealant. All right. Okay, moving on. So along with the favorable attributes I just discussed previously, they do have their drawbacks. They do rely on a visible fastening device for the connection to the desired substrate, and they do require field applied sealant to improve the weather tightness of the assembly. Now you're all asking yourselves a question right now, but Jeff, I've put these up without sealant before. Yeah, I know. Under code, they're typically limited to 3 and 12 without sealant or to 1 and 12 with sealant or solder joints. So also an additional concern is the panels are pinned at every attachment point, okay? Metal likes to move. If you through fasten it, it can't move because it's pinned, it's thermally locked. So the corrugation, and here's where I go off the tracks on this. The corrugation acts as a type of spring. I don't care if it's trapezoidal, sine wave, diamond, box, whatever it is again. The predefined point of flexation in the corrugation is what absorbs that metal's movement. So it acts as a sort of spring to buffer it against some things. Now, you've probably seen exposed fastener panels that have fasteners that are backing out, and I can touch on that later of why that happens. That is a concern, though. All right, moving on. Over time, excuse me, over time, the expansion and contraction of the panels do create an elongated hole at the screw location, and they may jeopardize the weather tightness. Use them on shorter panel runs with multiple laps, and don't use them on less than 1 and 12. I touched on that earlier. So, standing seam roofing systems, also known as concealed fastener. So again, the takeaway, exposed fastener versus concealed fastener. These are the opposite of through fastened, as they're concealed fastener. They are not nestable. You can't stack a 12-inch wide or a 16-inch wide standing seam panel that has legs inside of another 12 or 16-inch wide standing seam panel because they're the same width. They do not rely on laps and sealant. They rely on the standing seam leg. They are not through fastened. They are concealed fastener panels. So typically you're going to see a clip. Actually, all the time you're going to see a clip. Concealed fastener, through fasten, that clip engages the metal panel leg, spreads the load over the clip, and you're good to go. So let's move on. Standing seam configurations. There are many types of legs or standing seams that integrate to connect to one another to make that waterproofer. that waterproofing membrane. So the standard clip in the upper right, for example, is a male-female where the female leg engages the metal leg. In the middle at the top there, you have a mechanically seamed where the panels line together, then you roll them with a mechanical seamer. In the upper right, it takes it to the extreme. You seam it twice for a full 180 degree seam. And then at the bottom here, you have your traditional 1900s, 1920s batten style type panels. These are the panels that just form a right angle. And there's technically a little gap in between each panel leg, but you put a batten over the top. So there's a couple of examples of what it looks like. Let me see here. So they're designed with a tall seam to resist leaks anywhere from 1 inch up to 3 inches, I believe. Standing seam offers other performance in addition to the aesthetics. So they resist wind uplift substantially more as compared to through fastened panels. Provide sufficient attachment and thermal movement through the use of a properly designed thermally responsive clips. You can have unlimited thermal movement in these. They are not pinned necessarily. So the panel can expand and contract and move as the roof heats up and cools down. The clips are attached to the substrate and entrap the vertical panel leg. So the concealed fastener connections eliminate the elongation of the fastener penetrations due to thermal movement, which is very common in exposed fastener systems, and they greatly extend the weather tightness of the panel. Thermally responsive clips. All right, so to accommodate the longitudinal thermal movement on standing seam metal roofs, there's generally 2 types of clips, a 1-piece and a 2-piece, right? 1-piece clips allow snap together roof panels to move over the top. So that clip thermally entraps that leg, and the panel doesn't technically engage that clip and wrap around it because it can slide the entire length. So if you have a 200-foot long roof, that roof might be moving 1.5 inches, 2 inches during the day. So it can slide along that clip. 2-piece clips entrap the panel leg, and then they're mechanically seamed into the panel. So these clips have a limitation for plus or minus 1 inch of thermal movement. I can get into the positives and negatives of that way. Bearing plates. Okay, I'm gonna go off track again. Rigid insulation ain't so rigid, okay? Rigid insulation has a compressive value of approximately 25 to 30 PSI, depending on what you run with. The majority of them have 25, some even have low as 15. If you were to walk on polyiso on top of the roof, or I believe other rock wool has the same compressive strength, plus or minus 5, you would leave a footprint in it. You would see your heel, you would see the ball of your foot, and your toes kick off like you're taking a footprint, you know, from 10,000 years ago walking in the mud. Polyiso does not have the compressive strength. Insulation doesn't typically have the compressive strength that it takes to support a clip. Because of that, if you were to not have anything on top of the ISO and you fasten the clips directly through the polyiso, the clips under tension would sink into the ISO and they'd be flapping in the wind after not too long. So how do you handle this? Well, you either use a exterior grade gyp, like a 1/2 inch Densdeck, 1/2 inch Secure Rock, something like that, minimum, or a bearing plate. A bearing plate, also known as a snowshoe, distributes the weight, the tension of that fastener when it's screwed all the way in, and it distributes that tension across a larger footprint to distribute the weight to prevent it from sinking into the ISO. So bearing plates are snowshoes. They keep you on top of the snow from sinking in. They keep the clips from sinking into the ISO. Again, in lieu of this, you may use an exterior gyp. So what's this one here? Oh, long runs. So continuous standing seam panels can be used for long runs on low slope installations, but it's important to be aware of the limitations, like I said, in the movement of the clip. I'm going to go into that right now. So continuous standing seam panels at extra long lengths may be prone to installation damage, and they present far greater challenges when you're installing. So as an example here, say you have a large sports complex. Well, if you want to do one panel, that's fine. But now, how are you going to get it to the site? Truck can't carry a 200-foot long panel, can't carry a 150-foot long panel. So you have to roll form on site. Okay, great. That requires one man per 10-foot stick. That requires a crane with a spreader bar, which is very expensive to rent. That includes site control with perfect wind conditions and so on. So yeah, you can roll a 150-foot, 200-foot long panel. Now get it up to the roof and install it without twisting the darn thing. So you damage and you throw out a 150-foot or 200-foot long panel. Okay, we can do that, or you can lap the panels, because 3 50-foot long panels are much easier to handle, can be shipped via truck. So you're going to save money. You don't need a crane, don't need a spreader bar, don't need site access, site control. You don't have to have 20 men to move one panel. You only need 5 or 6, and so on. So there's pros and cons to long panels versus not, versus lapping. So yes, you can on-site roll form, no problem, but there are also other considerations to take into mind in addition to what I just said. For example, some manufacturers just don't offer it. So if you have a public bid spec, be aware of that. Number 2, they must be UL certified. They must be operated by factory technicians. You must have follow-up servicing on them. So I've seen all of these things violated. And again, I'm going to go off track real quick right here. So there's certain companies that sell their roll forming machines because they're not what am I looking for? Trademarked. They're not. They're able to be purchased by others besides that one company. It's not a proprietary seam or leg. And you'll have these companies buy these machines, and they'll go off into the middle of nowhere, like up in Alaska, or they'll go off into the middle of the desert and so on, and they'll do these projects with a roll panels. Okay, great. That's not a factory certified technician, number 1, that's from the business. It's just a roll former that has the same profile. That may or may not have the exact same testing as all the other panels. It may or may not have an ER report, right? It may or may not be UL certified. So you need to be really, really careful when you're using on-site roll forming to make sure that everything is on the up and up. This one is substrates. So available in the market are non-structural metal roofing panels. They're designed to shed water in sloped applications over solid substrates, as well as structural metal roofing panels designed to resist standing water over both solid substrates and open framing conditions. With limitations based on wind uplift, condensation, etc., they can be installed over wood substrates such as solid wood, decking, plywood, nail base, insulation, SIPs, concrete, whatever your heart desires. Metal roofing is also easily installed over steel substrates, including structural steel decking, light gauge, heavy gauge, structural secondary framing components in new construction and retrofits, and in some cases with the use of bearing plates. Again, the snowshoe. Metal roofing can be installed directly over selected types of rigid insulation, and cover boards, and will act as a non-combustible Class A covering in fire-rated assemblies. Okay, this is one of my favorite pictures, because just because you think a substrate's flat doesn't mean it's flat. Metal will follow the substrate. It's not as strong as you might think. It doesn't bridge gaps as well as you might think. There's always some deflection. So make sure your substrate is solid. Write that into your specs. Inspect in substrate, shim as needed, and so on. But again, here's proof that metal follows what's below it. Underlayment. Okay. Underlayment material options for a metal roof can include felt, paper, synthetic membranes, mod bits, and so on. I have to talk about that, but what I'm really going to hone in on here is the only membranes that you should be using, in my opinion, are high temperature, multi-mil thickness, so a 40 mil, 35, 40, 45, 50 mil thickness, peel and stick, high temperature metal specific underlayments, okay? If I had to re-roof my house, I would use an ice and water shield instead of paper. Asphalt impregnated paper, and if you would like to see this, email me after, can and will re-emulsify under the high temperatures underneath the deck. It will then run and leak down the sides of your brand new building or your retrofit. This happens. I've seen it more than once and I've got pictures of it. So absolutely the takeaway here, you need to use a high temperature, peel and stick, 40 mil, ice and water shield type underlayment specifically designed for metal to alleviate this concern. Also, if your metal's coming in down the road, this stuff oftentimes can be left exposed for 90, 120 days and your roof is waterproofed in. So that's my take on that. Don't really want to touch this one too long because vapor retarders and underlayments can be building specific based on building type and so on. You know, if you have an art museum with a high occupancy and you have to keep it bone dry in there so it doesn't damage artifacts as compared to an indoor pool and so on, these things can change. Again, use a 40 mil, peel and stick, high temperature. If I haven't said it enough, high temperature underlayment. Okay, so what is this one? This one is gauge. A change in material gauge will affect both positive and negative load carrying capacities of the metal roof panels. I know that's probably 101 for you, but you got to pay attention to it. Due to the nature of exposed fastened roof panels, a heavier gauge material is generally used to accommodate requirements for positive loading only. I know that's pretty much roofing 101, right? With exposed fastener panels, 26, 24, and 22 gauge are industry standards. 20 and 18 gauge are available for some profiles for added durability or greater positive load carrying capacity, and we can manufacture those. On the other hand, standing seam roof panels are much more dependent on the strength of the clip, right? And the panel engagement, pull-out value of the screw. So those are tested in 24 or 22 gauge steel. Although some test data is sometimes limited, both exposed fastened and standing seam panels can be also provided in your choice of metal. So aluminum, copper, stainless, whatever you want. I will let you know, again, I'm going to go off track here, that steel performs better than aluminum when in sheet form. So for example, if you have your new aluminum car door panel parked at your Safeway or Bel Air, wherever you shop, next to your grandfather's or at this point, your great grandfather's truck, and a shopping cart hits that door, steel probably won't dent where aluminum will. Also, your grandpa or great grandpa could take off the door panel and hammer it out from the backside and it'd be good as new. Whereas with aluminum, it doesn't have the memory. So you're looking at a new door panel. So aluminum does have a couple drawbacks in relation to that. Yes, I understand it's for conditions, salt water and so on. It does perform better from that standpoint, but we're going to get into that during paint systems. But what I want you to take away from this one is there are different performance attributes for each type of metal. All right, any questions so far?
Yeah, hey, thanks, Jeffrey. We've got a couple of quick ones. And you talked about underlayments and the preference one, but on a really basic thing, when you're installing over rigid insulation, do you require an underlayment?
Okay, so this is a fantastic question. Kudos to whoever asked that. You get a gold star for today. Underlayment can or cannot be used. It is your choice, depending on what your building application is. I typically like to see underlayment used on top of the ISO before bearing plates as a belt and suspenders type approach. However, that being said, I have seen numerous installations as well that just go straight over the top of the polyiso or rock wool, whatever insulation you're using. So super good question, and the answer is it is up to the designer's intent. However, if I was involved, I'd want to see underlayment on there.
Thanks. Another question about 26 gauge is usually, and we're off beyond my understanding here, different gauges come in different KSI ratings. And 26 gauge is usually 80 KSI and 24 usually 40 or 50 KSI. Is that all correct?
That's generally correct, yes.
Okay. All right. That was, I think, just a clarification on those. So, all right, keep on going. I've got some more questions, but we can get to those later. Thanks.
Okay. Yeah, no problem. Real quick, I do want to touch on that gauge real quick. So 26 gauge, 28 gauge, 29 gauge, you're generally going to see on your super industrial applications, or if you build a metal building in your backyard to house your RV or like a workshop or so on. Those are much less expensive as compared to the 24 and 22 gauge panels. It is a night and day difference when you start to get from 26 into 22 gauge. I'm going to touch on that again here. So coatings, right? AL, aluminum zinc, also known as Galvalume, also known as Zincalume. No difference. Kleenex or tissues, Charmin or toilet paper, right? It's the same thing, different names. It is the most widely used metallic coating for the corrosion protection of steel in the industry. 55% aluminum, 45% zinc by weight. Again, 55 aluminum, 45 zinc by weight. This product is referred to as Galvalume Zincalume. The aluminum component provides the corrosion protection to the steel sheet with the corrosion warranty. The zinc component provides the sacrificial edge that protects the material during cuts, okay? So those two components are what give this coating such a fantastic industry username and trade name, right? It's by far the absolute best coating. When used for low slope roofing, Zincalume coated sheet performs very well, lasting well above 30 years without corrosion failure. Hot dip steel sheets are available bare, unpainted, with up to a 25-year warranty against rust and perforation and so on. So this product is also used as a substrate for a pre-painted sheet when a more decorative finish is desired. So again, the metal comes in. Here's where I go off track again. There's this big roll of metal toilet paper that's 4 foot or 4.5 foot wide by however thousands of feet long, 4,000, 5,000, 6,000 pound coil of metal rolled up like a big roll of toilet paper. It comes in, it gets run through the Zincalume Galvalume coating machine. That is now what we refer to as bare steel, okay? Bare steel, when we refer to it in our industry, again, does not mean steel straight from the smelting facility or the electric arc furnace, okay? It means it has been coated with Zincalume or Galvalume, or galvanized, which I'll touch on in a second. That's bare steel. So you can use it like that. You can put it up on a roof if you, or a building if you want that reflective, nice silvery look, right? It looks fantastic. Or you paint it. But in order to paint it, it has to have the base of Zincalume or Galvalume on there. So it acts as the base coat to adhere paint to. So back on track. Zinc coated steel. That's galvanized steel, okay? It does provide the same, some protection, not the same, some protection, and the self-healing characteristics of zinc, but it is not warrantable. What's that, Jeff? Say that again. Galvanized products are not warrantable. Therefore, please, please, please do not specify G60 or G90 unless you absolutely want it for whatever reason. Specify Zincalume Galvalume because painted or not, it has a substrate warranty where galvanized does not. Moving on, paint options. We have different types of paint for different products. Silicon modified polyester, SMPs, polyester, or Kynar 500s, also known as PVDF, polyvinylidene fluoride. So silicone modified polyester paint coatings typically have a 20-year comprehensive warranty and are generally used on lighter gauge products. SMP and polyester paint coatings complement the industry with our economical paint systems, but they do have drastically decreased chalk and fade values. But they support that part of the market that's looking for cheaper stuff, right? Now, there's another reason for this. We're going to go off the tracks again. You have a piece of paper and a piece of cardstock. If you hold them in either hand, the cardstock's going to remain generally flat and be able to defy gravity, where the piece of paper in your other hand may bend down. That's 26 gauge versus 24 gauge or 22 gauge, okay? Lighter gauge metal flexes more. Because of that, it needs a less brittle paint system that can flex with it, i.e. SMPs or polyesters. Whereas the heavier gauge products that have that resistance, well, let's throw the best paint on there, right? Let's throw something like a PVDF. So Kynar 500 is the most widely used in the architectural market. It's a paint system containing a minimum of 70% fluoropolymer / Kynar resin. The chalk and fade qualities outperform polyester, urethane, silicones, and acrylic coatings by far. Kynar paint may be warranted for up to 40 years. This slide is outdated and I should have fixed it. And I've said this to myself during the last 10 presentations. I have to take care of that. Up to 40 years now at this point. When Kynar 500 is coupled, again, with the zinc aluminum galvalume substrate, which you're going to specify, right, over G60 G90s because it has a warranty, the product exhibits exceptional color stability, chalk resistance, durability, abrasion resistance, chemical resistance, and so on. So for severe corrosive or saltwater environments, we have, well, I should say paint manufacturers have developed alternatives to the industry standard 1 mil Kynar-based coatings with high build primers, Kynar top coats, multiple layered coating systems, and so on. So these performance coatings can offer long-term warranties comparable to warranties offered under less severe conditions. So what that means is just because you're doing a project in the Puget Sound, or you're doing a project in Santa Cruz on a nice beach house or a restaurant, and you're right over a body of water and boats pull up to dock and get out and go have lunch at your establishment, doesn't mean you have to do aluminum. You can do steel with the zinc aluminum galvalume substrate with a high build marine grade finish paint system, okay? Or we can do aluminum and so on. But let's have that discussion on a project specific basis. So paint, here's how it goes down. 24 gauge base steel. Then you run it through the zinc aluminum coating machine, right? That's what I said we call our bare of steel. Then we paint it. Or we can do away with the paint. You can just have quote unquote bare zinc aluminum galvalume steel. Moving on. So when specifying paint, check the warranty carefully and verify the warranty coverage. It is absolutely critical to examine and compare more than just the length of the warranty. A longer duration is generally not as comprehensive and may cover only adhesion to the paint of the steel. Chalk, fade, oxidation are equally important. Make sure that's covered as well. Also, what's the remedy that the manufacturer is willing to provide? So this slide just basically says not all warranties are equal, right? Sealants, let's move on. We're going to go through this one quickly. Sealants protect against moisture intrusion at the roof, exposed panel flashings, laps, or conditions, and so on. There's various types of sealants used, but typically we use only two. Number one, the non-curing butyl. This is typically tube applied. This type of sealant should be used in any areas on a metal roof that are subject to dynamic movement of the panel, i.e. thermal cycling, including panel side laps, end laps, flashing attachments, or any other metal-to-metal connection. Not only does non-curing sealant protect against capillary action, it also allows the panels and flashing to react thermally. So not only does it prevent water that might technically roll uphill, capillary action, and get sucked inside, but it also protects against thermal movements. The panel can expand and contract. This stuff is gooey forever. It doesn't compromise the integrity. The sealant non-curing butyl will never dry out or break down when not exposed, okay? Provided it's not exposed, will not break down ever. I've seen this stuff 20, 30 years down the road and it's still gooey. Okay, next one. Extruded butyl tape. Well, kind of the next one. Butyl tape is typically available in rolls up to 50 feet long. It can get in different sizes and so on. In widths, this is almost looks like a roll of masking tape, but it's thick, right? The sealant should be used in all non-exposed applications. Again, it will break down. It's butyl tape. Butyl tapes are in essence the exact same as non-curing butyl sealants, not tube applied, but they're tape applied. So what thickness, what width, what so on, right? Moving on. Here we go. Here's the second sealant. My apologies. Single component urethanes, tube applied. Single component urethanes are used for any area of the roof that requires sealant to be exposed to sunlight. These sealants can be used when integrating with a non-metal surface like masonry block, etc., and they come in colors. So you can get that blue sealant with your blue panel. What's this one here? Specifying a metal roof solution. This is, let's review some specification considerations for the metal roof installation. So material quality and source. Testing. The quality manufacturer can provide actual test data easily. Wind uplift, ASTM E1592. Test to ultimate failure. I'm going to hone in on this down the road as well. And manufacturer qualifications are two key areas to focus on. So attachment of the roof to the substrate, installer qualification, finish warranty, and so on. Verify submittals. We're going to blow through this because I know there's other stuff to get on. Energy efficiency. Let's explore the energy efficiency of metal roofs, I suppose. Let's jump in. Solar panels, environmental impact of metal roofs versus alternative roofing materials. So as I'm sure you know, metal roofing contains recycled content. It's sustainable, lasts much longer than most roofing, and is 100% recyclable. Boom, recycle it. However, in terms of green building, it's important not only to compare the life cycle sustainability of a product, but also its full range of environmental and social impacts. To that end, again, I'm going to skip through these couple because we could spend an entire hour on this. There's various software programs that dive into it. And if you have questions on this kind of stuff, living building, LEED, whatever you have, let's jump into this kind of offline. Cool metal roofing. I'm sure you've heard that name, Cool Roof. I want cool blue. I want cool colonial red. Or I want cool matte black, right? All that means is it's got infrared reflective pigments incorporated into the paint that give it higher reflectivity values even in the darker colors. For instance, a roof with a normal pigment may have 0.07, but improved to a 0.32 with the reflective pigments. So cool roof, when you see that, or cool metal, cool before a color, means our paint gurus have figured out what to put in the paint that doesn't change its color, but makes it reflect more light. So cool roofing typically has SRI's values, emissivity values exceeding 80%. A cool metal roof will reflect solar heat back into the atmosphere, lowering both inside temperature of the building because your intakes at your HVAC units are dropped, your intake temperatures, right, and the surrounding environment. So really, what these slides come down to is if you were going to go on a boat and go fishing or water skiing, would you wear a white shirt or a black shirt? That's the difference, okay? If you want to keep it cool, go with the lighter colors. So in specifying a cool metal roof solution, look for the paints that have higher SRIs, LEED, Energy Star. Actually, Energy Star Sunset, it has as of June 1st of this year. Pay attention to the differences in SRI. If you're in California, anything below 2,400 square feet that is conditioned space that has a low slope, which defined under code is anything under 212. 212 is not considered low slope, but anything under 2 and 12, you have to have a minimum SRI value of, I want to say, 82 off the top of my head, which is basically white, or off-white. But we can talk through that one-on-one if you have questions. Okay, PV, a metal roof solution, very easy to incorporate PV. So I know I'm not supposed to mention trade names on AIA, but there's manufacturers, specifically two that I have in mind, that make these clamps. Contact me after if you want to know who they are. That clamp onto the standing seams of the roof. You set them and you can mount whatever the heck you want up top. Want to throw up signage? Go for it. Snow melt? Sure. Snow retention? We can do that too. PV? Yep. These clamps don't put holes in the roof. They minimize it so you have one hole where your PV cabling goes through, right, or something like that. And it's just, they clamp on the seams. They provide increased wind uplift, even though you're putting essentially a sail on top of that roof with the PV system. But this is the way you should do it. Reach out to me for trade names. You can see the clamps going down, then the framing, some cabling, and then your PV. So let's go through this one real quick. I've already talked on this. Dissimilar metals, I'm sure you all know that from your first classes in school, and clamp-on systems do not void a warranty. They're the best way to go, but damage from them, if they're installed incorrectly, isn't typically not covered. Solar panels, all right, going on. Hey, questions again?
Hey, thanks, Jeffrey. A couple real quick ones. Do you need a lightning protection system with a metal roof?
The answer is no. You do not need a lightning protection system, but if you are interested in learning about how I would go about doing this, I have an entire file on this that we can talk offhand. And a lot of that is going to depend on your site-specific conditions, the height of the building, and so on.
Another question is about the cost of metal roofing with the cool coatings, the solar reflectants. Is it a higher cost than the without?
It is not. So from our manufacturer standpoint, I'm going to answer this question based on AEP. Every single paint that we have is a cool paint. So no, there is no higher cost. Just telling you what they mean. Cool means that someone with extreme chemistry knowledge, way beyond what I would even fathom, has figured out how to drop the SRI, so excuse me, increase the SRI of the paint without changing the color by adding a pigment.
Final question here is, this one just kind of came through, and can you talk about, is there any effect on heat transfer aluminum versus steel have on the building? So
the answer is yes and no, and that is a very astute question. Whoever asked that, well played. There's also things going on right now of heat island, and they're going to start rating walls as well down the road to see how much is reflected off. Like there was always that story of the Las Vegas casino, right, that had that rooftop pool, and it was reflecting light off the wall paneling, and the pool was getting superheated and people were getting sunburns. So very astute question. Yes, there is a slight difference between steel and aluminum, nothing to take into drastic consideration, but if you wanted to get involved in the heat island effect and radiance and so on wall cladding as well, talk to me offhand. But that is a high concern, and it is being dealt with right now. There's going to be something coming out in the next year or 2 years on this, I guarantee you.
Thanks. Just a note to people, we're not going to get to all the questions today. Some of the questions we're getting are really specifically technical about individual projects or things, and I would encourage you to follow up with Jeffrey after the presentation on those kinds of things. But continue on, please, Jeffrey.
All right, so let's get through these real quick. These are design and installation considerations that come in the form of testing and so on with the metal panels. So wind uplift, air and water infiltration, expansion and contraction, also known as thermal cycling, drag load, which is the key again, and then some installation details. Can everybody hear the wind? Or is it only on my side? Hopefully you can hear it. So
it comes through slightly.
Slightly? All right, cool. That's the one slide where there's quite a bit of volume on that with the wind. So wind is one of the essential factors in roof design. The non-continuous attachment of metal roofs make them very susceptible to wind uplift, which is defined as the upward force exerted by wind traveling across a roof. So poor design, non-compatible materials, not enough clips and so on. All this plays in. So let's talk about this. So I'm going to go through this quickly because I know this is engineering more on that realm, but listed on this slide, there's a couple different key factors. So exposure, the surface irregularities in the environment, building impact, wind loading. ASC 7 defines 3 exposure categories, B, C, D, right? Basic wind speeds, ASC 7, building height, roof slope. Let me back up, not most. Some manufacturers can provide these calculations for you based upon your site-specific wind conditions and let you know what your appropriate clip spacing should be for your product. Structural standing seam panels are tested under ASTM E1592, which is the standard test method for structural performance of sheet metal roof and siding systems by, oh goodness, what is it? Uniform, oh, it's on the slide right there. Uniform static air pressure differences. I was trying to do it from memory. All standing seam metal roof panels should be tested under UL 580 at a minimum. Remember earlier I said I'm going to go into what testing is? Well, here we go. So ASTM versus UL, right? ASTM, well, actually, let me pause right there. Let me get through this next slide. So you should subscribe to a UL follow-up service as well. ASTM and Factory Mutual also provide testing. Unlike UL, which is pass-fail, UL, pass-fail, okay? ASTM and FM take the panel to failure. This is absolutely key. So let's say that you are in your final class in your year of college and you need a C to pass it. Well, if you get a C or above, you pass. Great, that's UL, okay? ASTM and FM is the one that says, great, you passed the minimum. Now let's push it and see where you really fail. So just because a manufacturer has UL testing, oh yeah, we're UL certified, great, fantastic. That's the average. Get your ASTM and push it and see where it's going to fail. And that's where your evaluation reports and so on come in, which I'll touch on here. So air and water infiltration rates, in addition to wind uplift, metal panels should also have air and water resistance, which are acceptable to the industry. This is tested through ASTM E1680 for air and E1646 for water. Now, going back to the lapped panels example earlier, you can also get these tests for lapped panels, 1680 and 1646, and with proper sealant placement, also exposed fastener panels can provide adequate air and water infiltration control. So standing seam and exposed fasteners, concealed and exposed fasteners can both hit this metric. And again, structural standing seam panels, again, the concealed fastener panels that required mechanical seaming in the field with panel-to-panel end laps due to long lengths. Again, my example of a 150-foot long panel versus the 350-foot long lengths. You can test under 2140, which is also a panel-to-panel end lap pressure head test, which is an end lap with, I believe, 6 or 8 inches of standing water over the lap condition for a period of 6 hours with no signs of leakage under positive pressure. So if it gets drawn through that panel, you fail. Evaluation reports. Again, these evaluation reports do not all hold the same value as just UL. Okay, UL does not push to failure. It's a pass-fail test. ASTM pushes to failure. The results of an ASTM test are therefore much more representative of the panel performance, and the values can be extrapolated out. Evaluation reports are independent third party as compared to UL, and FM. Don't specify FM unless you're doing an FM insured roof. Okay, it makes things much more difficult because it's a much more stringent test to meet. While certain panels can meet it, don't specify FM unless you're FM. Okay, let me see here. What's this one? Oh, expansion and contraction. All metals in roofing expand and contract with temperature, i.e. thermal cycle. You must take this into account. buckling of sheets, tearing at seams, loosening or pulling through of fasteners. If you have an aluminum roof, excuse me, not an aluminum roof, an aluminum patio cover in your backyard, and you walk out for your morning coffee and you hear a pop or a boom, that's the metal panels moving. And they're pinned. So if you had longer length panels, they would start to buckle. Rates of expansion and contraction differs with the table on the side. Generally speaking, steel is 1/8 of an inch over a 10-foot stick, and aluminum is 1/4 of an inch over a 10-foot stick. So this is what evaluation reports look like. You're going to see the valid through date, and you're going to see what panels are tested along with the results. Okay. So real quick, how to read these. I know it's small. You're going to take let's look at the right-hand side one for the outward. You're going to take what the substrate is on the far left. Is it cold formed steel? Is it wood? What is it? Or, is it metal deck? You're going to go with the gauge, 1 over, the amount of fasteners required per clip. And then after your site-specific wind loads are determined, i.e. you need, 40 pounds per square foot or something, you can pull your index finger over and find out what your maximum allowable span is in between those clips. So we can touch on this later if you have any questions. Let's get into some details. Okay, so there's 3 different ways to accommodate for thermal movement: at the end of the panel, top of the panel, or both. Typically, panels are pinned at the high end or at the slope of the panel for drag load. They accommodate movement at the low end of the panel. They expand down slope. The high end is pinned, fastened to keep them from sliding down, and it provides a direction for thermal movement. The low end of the panel is then hemmed around a hook on a cleat to allow it to expand and contract at the eave or low side of the panel. To accommodate at the high end of the panel, the low end is pinned to the structure. Okay, the high end must float. This method requires exposed fasteners at the low end of the panel, which may be of an aesthetic concern. The third method is to allow expansion and contraction of both the high and low ends of the panels. This requires pinning somewhere in the middle, usually at a lap. This is generally done on very long panel runs, 70 foot plus, because that's what length we can truck out, right? So if you go over 70 foot, it's like we'll do 2 panels. Where expansion or contraction is great, so it makes it difficult to allow for just at one end, or you're using multiple panels, or if the thermal movement exceeds that of the clip. So if you have plus or minus more than 1 inch of movement anticipated based upon steel at 1/4 inch per 10-foot stick, you have to pin it someplace in the middle because that clip can't move beyond the 1 inch capacity. So at these instances, the overlap between the hidden cleat and the turn under end of the panel at the eave needs to be increased to accommodate thermal movement. Do not pin the panels in more than one location, because this will thermally lock whatever's in between those 2 pinned clips. Okay, you have to allow it to expand up and down. Here's an example, right? Because I like pictures. Typically, a truck is 70 foot truckable length. So let's limit it to 75 foot. We're going to throw it up there, pin it at the top, whether that's a shed roof or a ridge, doesn't matter. It's going to expand down slope. Now you have a big building, 150 foot, say it's a 1/4-12 slope, right? Very low slope building. And you have a 150 foot long panel. Well, pin it at the midpoint and allow it to expand both up and down. So if the panels are fixed at the high end or ridge condition, free movement is required at the low end or eve line. Here's how you do it. There's a hem that goes around a cleat, done deal, right? Pictured here are examples of proper and improper eave details. So make sure you do the proper one for long-term success. Knee joint. Okay. So I wrote an article for Paul probably 2 years ago at this point that talks about this. If you want to do this, reach out to me and I can send you the article in Modern Trade as well. This is a knee joint. I know everyone on this call thinks this is a cool detail, because it is. You want to run a roof from the ridge to the eave, turn it down the building and have it go down so it looks seamless. Or you have even a 2-foot little mansard, right? Okay, here's the thing. When you turn at the eave, it thermally locks the panel from being able to expand at the eave because it's turned, it's pinned. So if you do not allow for expansion at the top of the roof, i.e. upslope, which is, I know you were thinking, but Jeff, why would I ever want to allow it for upslope? This is why. This detail right here, and we can do it with special considerations that are made. So reach out to me if you want to do this one. So a knee joint or a kneecap is used to cover the cut vertical panel rib of the standing seam roof that transitions from one fascia to another one in a continuous piece. It allows for clean lines, but you have to pay attention to how you do it. You need to take care when you're doing this. So it expands upslope, number one, and number two, don't do it in snow, please. The freeze thaw is just going to pop it wide open. So we can talk about this on a project specific basis. So here's how you accommodate for movement at the top of the slope. You see the step in that ridge cap? I believe it's identified by the right yellow box. There's a step in that ridge cap. That acts as a point of flexation, a little hinge to allow the panel to flex with that ridge cap. The drag fasteners don't penetrate into the substrate, so it allows the panel to move back and forth. For longer roof runs, here's that detail, the fixed lap detail, which is with the fixed clip. Again, this requires both the high and low side to float. This is done generally on very long panel runs or on barrel roofs where the distance is so long that it makes it difficult to allow for thermal movement at one end or you have a lap and so on. So let's move on. Staggered panel laps. Alternate them. There's a couple different panels you can do full, like 200, 250 foot long runs on, but again, those are all going to be roll formed on site and they're going to be T-seam or bulb seam panels and very, very costly. And again, that's if you want to deal with spreader bar rental, crane rental, one man or woman per 10 foot length, on site control, crowd control, blocking of the area, perfect weather conditions, and so on. Otherwise, do a lap panel. The fixed clip detail operate on the same principle as a fixed lap. They require both the high and low ends of the panel to float. Fixed clips are most commonly found on long length panels or at the radius of the application. So here's what a fixed panel, fixed lap, fixed clip looks like as compared to a floating clip. Here's the other reason. You want to fix it in the middle of the radius for drag load. Panels can't fully expand or contract around the radius due to the curve, right? So if a panel if a panel floats around the radius without a point of fixity, there's going to be oil canning everywhere. You fix it in the middle, allow it to expand down each side. Okay, varying panel width and thermal movement also must be considered when detailing the full-length roof panels at the gable ends of the building. Okay. So in most cases, installers will not be able to utilize a full panel width at the ends of the building. So this detail allows for the cutting of the panel to the necessary width and the field bending of the panel edge up 1.5 inches or whatever it is. The 1.5 inch panel turn-up is also used to protect against infiltration of wind-driven particulate. Once the panel's been turned up, panel edge is inserted into the receiver trim and secured against wind uplift. This detail also allows for free and unrestricted thermal movement of the panel within the receiver trim. So now we know ridge, eave, radius, turning down a wall with a roof to wall, and the gable ends. Drag load. Panels are pinned to allow the panel to move freely under thermal load and resist drag load by the weight of the panel, live loads, snow loads, and so on. Snow and ice imparts a live load on metal roofs, so make sure you pay attention to it. I've got horror photos. Cold climate designs. Metal roofs are generally the choice in cold climates. You may need to address ice dam formation due to building heat loss, radiation, vapor drive, and so on. Cold roof systems that keep roofs temperatures near the same as the temperature of the outside air may be the best for preventing ice dam formation. If you want to talk snow melt systems or you have site-specific considerations on this, please reach out to me after this. Always make valleys and so on much larger in order to accommodate for the increased runoff. I've got a picture of a nice wide valley, which I wish was in here. Snow retention, you can use those panel clips I showed you earlier and put whatever you want on them, from signage to PV to snow retention. We recommend that roof designs that limit the need for snow retention devices, just in case it places unintended loads on the roof. If they are required, please reach out to us so we can help walk you through it. Again, use the clamp or screw-on type. Hey, never mind, I did put it in here. Here's the valley picture I was talking about earlier. Awesome. Make valleys wider if you have conditions like this, because you have to keep in mind the panels at the bottom are running off only from those lower panels. The panels at the top only have runoff that is condensed from those upper panels. So you may have 2 panels at the top, but at the bottom, it's every single panel run above it. So by the bottom of a valley, you may have, if you have 50 panels above it, it might be, just fast moving river as compared to a trickle up top. So make sure you accommodate for that. Okay, this one's my pet peeve. Pipe boot details. I know they look basic. Okay, they're used all the time. Ventilation, whatever, right? Please center them on a rib. Center them on the middle of the roof pan so the water can run around either side. Also, please don't cut the size of the opening to the size of the pipe. If you have a 3-inch pipe, take into consideration the movement. Is the pipe penetration at the bottom of the panel run? If so, you may have an inch of movement in that panel. So the opening in the panel needs to be bigger than the pipe itself. Also, if you have generator, some sort of exhaust or vibrating pipe, you have to accommodate for that. It's not only the panel movement, but the movement of the actual pipe. Also, this pipe penetration should never be screwed into the substrate. So if you have a solid substrate below this, don't screw the pipe boot into the wood or the metal deck below, because you're pinning it. And now the roof wants to move, but the pipe boot can't. The pipe boot is only affixed to the roof, so it moves in conjunction with the roof. Think if the pipe boot is a slinky. You're going to hold it in front of you, and your other hand is going to move the top of that slinky from left to right. That's what that pipe boot wants to do. So I know it's basic, but you wouldn't believe how many issues I've seen here. So everything I talked about happened here. Roof moved, and the pipe boot wasn't big enough to accommodate for this. If you have a large section that goes on the middle of a standing seam, use a home plate detail. The cut rib home plate detail, which is shown here, should be used on all penetrations that come up or near a vertical panel rib or are larger than 1 panel width. The rib should be cut with a shear, again, never a blade or a torch, but that's what you want to do for a larger or off-center pipe boot. What not to do, how to do it correct. If you ever have multiple penetrations or something bigger than 2 panel widths, okay? So pipe boot for a single one, a home plate detail for 2 panel widths. Anything more than 2 panel widths, you use a curb. Again, crickets. So use them for solar tubes, HVAC equipment, ventilators, whatever you may need, okay? But anything bigger than, I like to say, 2 panel widths, use a curb. As you can see on the left here, this picture shows it at almost 3 panel widths. All right, I think I made it through over time. My apologies, but I'm done.
Hey, thanks very much, Jeffrey. We are a little bit over. We've got a number of questions. I'm going to preface it by a lot of these questions are kind of referring back to some of the technical detail drawings that you showed here. And I think some of these questions would be answered if people had a moment to look at the drawing more. So okay. This is a reminder that people will be able to download the presentation tomorrow from a link in the email, and you will be able to kind of look at these drawings, the technical details more closely than Jeffrey's running through them quickly.
Yeah, I was trying to hit that hour, man. I could go for 2 on this thing.
I do got a couple of questions. One of the folks asked, most roofers shy away from kneecap joints. Are there other options?
So yes, oh my goodness, yes. And that was a very good question. There are other options. Okay, so I've got a whole file on this, but I'd have to dig through my internal files here. So let me try to explain this to you. First of all, don't shy away from that kneecap detail, okay? There are ways to accommodate it. We can make it happen. However, if you do want to shy away because you don't like it quite as well, what you do is you take that roofing system, you pin it up top, and you have it do an expanding eave detail. Standard, typical ridge to eave detail, right? At the end, you cantilever the panel over by 2 to 2.5 inches, okay? Then what you do is you take standing seam and install it on the walls. You tuck the standing seam up behind the cantilever, do your typical head closure and so on, but you line the seams up exactly with the seams on the roof. This is called a two-piece detail, and this is identified in the article that I wrote for Paul in Modern Trade. So if you want to see it, I can send that article out. Send me an email. But it's a one-piece detail versus a two-piece detail. The one piece is the kneecap, and the two-piece is the cantilever tucking up the wall behind it, so it looks quote unquote seamless from far away. But when you get up close, you go, "Oh man, that's cool." They just lined everything up, and it looks fantastic. So that's your other option.
Thanks, Jeffrey. 2 more questions, and I hope maybe I can ask these quickly. One of the person asks if you've got a roof beam, how do you ventilate the attic if it's a ridge beam, not just a roof beam, a ridge beam? How do you ventilate the attic in that circumstance?
Okay, so if you have, first of all, this question is assuming you need a ventilated space. So if you have the need for a ventilated space, like an attic or so on, or you want to do a ventilated roof underneath that panel, there are multiple ways to do this. The most common way is with a vented ridge condition. Okay, and let me show you that ridge condition right here. Okay, so you see the step in that panel right there? What you would do is you can put a perforated material underneath that so that the ridge would, the panel would be pinned at the ridge like normal. But this step in the ridge cap would be used to provide a ventilated space. Whatever ventilated space you need, you do the calcs on that. If it's 1 inch or if it's 6 inches, it's fine. And I can send you a photo if you want to see it. I've got one looking down as this is going together. But imagine this, you're standing on the ridge with 1 foot on either side, looking down at the ridge. It hasn't been installed yet. The panels come up together and they're pinned for drag loads. You just have that one little opening at the ridge. You're going to put your Z closure on and your piece of perforated aluminum or whatever you want to put there for your ventable space, whatever size, right? So you can get that ventable space. And then you put the ridge cap with the step over that. So it provides access to a ventilated ridge condition. That is a vented ridge, okay? The second way is there are vents that are manufactured within a panel width that you can install. So there's dormer vents and so on, whirlybirds. They make all of these that you can install in the roof and then paint to match the existing color of whatever you have. So if you have a colonial red roof, you can order these things, and when you order the panels, you get touch-up paint with it, and you paint them, it matches perfectly, and install them. And reach out to me if you want pictures on all of this. So number 1 is vented ridge. Number 2 are your dormers and whirlybirds.
Jeffrey, thanks very much. A great presentation, and listening to reading the comments and the questions here, I think everybody agrees, great presentation. As I mentioned earlier, and want to make sure I mention again, for those of you who are interested in certificates or getting AIA credits, that will all be handled automatically. Just give us 7 business days to handle it. That'll be taken care of. If you have any questions about it, you can follow up with me. You'll get my email address email tomorrow. As well in that email tomorrow, link to download the presentation, a link to a recording of the presentation, and also some information, and I think Jeffrey's contact information if you need to follow up on technical details. But thank you all for taking time out of your day and attending. Thank you, Jeffrey, for a great presentation. Our next webinar is going to be Tuesday, September 20th at 2:15 Eastern Time. It's maximizing envelope performance with IMP impregnated components, and it's being brought to you by Centria. And you can find the latest on all the webinars we're doing at our website, metalarchitecture.com/webinars. Thank you all for joining us. Jeffrey, thanks again very much. Great presentation. Take care, everybody. Have a great weekend.